Welcome to Module 6 of the Documentation of Contract Quantities class. We're still in Section A in the Doc Guide, and we will be discussing source documents. Field inspection reports and source documentation. We're out on our job sites, we're taking measurements, we're writing down measurements, making calculations, making notes, taking depth checks. Where do we put these items? How do we collect this information and document it for somebody else to see? A couple of common sources: the BC 628 or Inspector's Daily Report, field books, calculation files, weight tickets for paid by weight items, potentially cross-section paper for volume items, or spreadsheets. Spreadsheets are becoming much more common, especially with the transition to electronic documentation. Please note that if you're using I-Cores, the daily quantities reports are not source documents. They represent information collected from your source documents. Electronic documents uploaded to CMMS shall be considered the source documents, not the paper document anymore. You can see the final documentation requirements for more details. On this page, we're showing you an example of the IDOT Inspector's Daily Reports. You can find a blank copy of this on page 14 in the workbook if you wish to follow along. In this upper right-hand corner, we have our project information. What is the single most important item in this area that is absolutely required every time? That's right, the contract number, the IDOT contract number. Here we have the date of the work. Is it the prime contractor or a sub, and who was it? What kind of weather was going on during the work? Here we've got our item code number, or pay item numbers would go in this column. Any fund code numbers that we have would be in this column. Your pay item description of what we're working on, a location of the work. Try to be as specific as you can in this location area. Stations, left and right. Quantity and units in this column. So you're calculating your quantity, you must also have the pay unit with those quantities. In this column, we are tracking the evidence of material inspection that is required for each pay item that we put on the individual rows. Please note, for the purposes of the DOC class, this column is not optional if you happen to see this form again. Once you've filled out your row or multiple rows, you must choose one of the two boxes at the bottom. The top box indicates it's an estimated progress measurement. You would want to put your pay item number here for each one of the items that is estimated. You check this box if you've made a final field measurement. It doesn't have to be final for the pay item, just final for that measurement. Also, you should put your pay item numbers on this line for all pay items in these rows that are final. And note, you can find all the construction forms on the IDOT webpage. Field books are another common tool used to record data in the field, measurements, calculations, depth checks. Field books have very specific requirements. If you look on page A7 and 8 in the documentation guide, you will see field books are required for permanent survey records and your concrete superstructure pours. There are discussions occurring now that we may end up going to electronic documents for these to be more in line with the theme of CMMS, but for now, these are required in your field books. Field books are also required when you're not using pre-printed forms for PCC paving or Portland cement concrete paving or hot mix asphalt, HMA paving. If you are using one of these two pre-printed summary forms, you do not need to use a field book. What are some of the requirements for field books? Like I said, if you go to your doc guide, page A7 and 8, we can look and see what some of the requirements are. Field books must be hardbound. They cannot be spiral bound. There again, we don't want to be removing pages from our field book. What happens if we do? What happens if we rip a page out of our field book? Well, somebody else is looking at that field book, thinks that we're hiding information or removing previous information, so we don't want to rip pages out. Let's look at an example. Here's the inside cover of a field book. Here we have our if found to, please return. It says phone number is optional. Highly recommend the phone number. Once again, if you lose your field book out on a job site, how many people are going to pick it up and mail it to you? Not too many, but they'll probably give you a phone call and say, hey, I found your field book. You also need the contract information with our contract number being the most important part there. All field books must have an index or table of contents on the first page. It must index every single page in the field book that has writing on it. You can skip pages, you can designate a range of pages for different items. Let's say you used page 12 through 15 for your depth checks and you ended up needing more pages. You could come down here and say depth checks continued and have more pages. But every single page that has writing on it must be indexed. On page F14 in your dot guide, you can follow along and look at an example field book page. All field book entries must have pay item number, pay item description, the date, the weather, and who's doing the work, and then we need some calculations. This one was for HMA paving. Here we have our location. Here's our measurements for our length and width, and then our required mat thickness, the equipment that's required. We have some testing, temperatures of our HMA materials. Yield checks are required for HMA materials, so here we have a good section on yield checks. We will cover yield checks here in just a little bit. We also had short-term pavement marking, so we had that pay item number, description, location, and here's our calculation for our quantity. All in all, a very good field book page. Here we have our measured by, calced by, and checked by with our manual initials and manual dates as required by all paper source documents. This is not an example of a good field book. We don't have any pay item information. We've got lots of documentation and lots of numbers and some drawings and maybe some calculations, and we got some crossed out stuff. Very messy and extremely hard to read and does not meet the requirements of a field book. Handwritten initials and dates are required on all non-electronic source documentation. If you're working in CMMS, initials and dates can be electronic. If a measurement is made, we need a measured by and a date. If we make a calculation, we need calculated by. If you have calculation, we need checked by. Initial your own work. Do not initial somebody else's work. Some useful references in completing our calculations and checking our work. In section D of the dot guide, we've got some math help. Pages D7 to D11, we have formulas for calculating areas and volumes of shape. On page D12, we have some recommended checking procedures that we will talk about. Page D13, we have some common areas that are miscalculated. And on page D4, we have some common conversion factors. On page D12 in the dot guide, we have some recommended checking procedures. Here we have a simple drawing with a calculation. Here are my measurements of this trapezoidal area. And I'm calculating the area here. As the checker, I'm checking these little tick marks to show that I'm checking that, number one, they used the data values that they show on their measurement. Here I'm ticking off the 1/2 because they're using the trapezoid formula, 1/2 of the parallel sides times the perpendicular distance between it. What are we doing here? We are converting our units. We're going to calculate this. It'll come out in square feet, but my pay unit is in square yards. So I have to divide by 9 square feet or multiply by 1/9 to convert from square feet to square yards for my pay unit. Very important. Remember, any place a mistake might be made, sooner or later it will be made. Checking involves much more than just looking at the math. If you type in somebody else's formula right in the calculator, it's highly likely that you're going to get the same answer, and it could be wrong. When you're checking someone else's source document, we're also looking at, do they have the right pay item? Is it in the right area of the job site? Is the stationing correct? Do they have the right pay item number? Do they have a fund code? Is that correct? On page D13, we show you some of these miscalculated areas. Not all of the shapes out in the field that we measure are squares, rectangles, triangles, and circles. Those are easy, the most common. Sometimes we have irregular shapes. We need to break them up into shapes we can calculate. Here we get a triangle and a trapezoid. I can calculate those, but I can't average the opposite sides and multiply together. Doesn't work. Parallelograms, here we take the width and the length, not on the skew. That would be incorrect. Here we have an area which may be, here's the road and we're going up an embankment for sodding, seeding, mulching, something like that. We're taking individual height measurements right here, and we're going to average. We're going to calculate this square area or this area. They're not squares, they're trapezoids. And this area separately and add them all together. We can't average the heights and multiply by the entire distance. It just doesn't work. Planned Quantity Acceptance, or the BC 981 form. What is it? Planned Quantity Acceptance is a tool that can be used on source documents to eliminate the need for measurements and calculations every day of production. It's based on 3 points. 1, the existing plans are accurate, meaning they're well represented by the actual job site. There's no signs of recent construction. Lines and grades of existing match what's out there right now. Number 2, the planned quantities are accurate. So we have to do some checks and some calculations to make sure the designer has an appropriate planned quantity and it matches what we think we're going to do in the field. The third is the work is built according to plan. So we're going to go out, execute the work to the lines and grades in the plans. If we can satisfy all 3 of these conditions before we start the work, we can agree to the planned quantity. We don't have to measure. We can estimate on a daily basis. And when we're all done, we're going to end up paying the actual planned quantity. The method of measurement states requirements shall conform to Article 202.07a. So if you're looking up a pay item and you want to know, is it eligible to agree to planned quantity, you have to go to the method of measurement for that pay item and look to see the reference to 202.07a. If you look in your spec book on page 81, 82, you will find Article 202. Section 202.07 is the method of measurement for earth and rock excavation. Here, item A states contract quantities. If you read this paragraph, it describes the 3 conditions, that the lines and grades on the existing site are accurate, the planned quantity is accurate, and we're going to go and execute the work according to plan. It further states that if there are errors discovered after the work has been started, you can make appropriate adjustments. It doesn't mean you have to scrap the planned quantity just because you have changes in the field. You can document those, subtract them, or add them to that planned quantity and continue on. Even when the plans are altered by revised plan sheets, you can still revise planned quantity. However, we have to agree before we start the work. Later on, it talks about here in the revisions, if they're made part of the contract, we're good to go. So this is the first instance, 202.07a, where IDOT in the spec book describes this planned quantity acceptance. On pages 156 and 157, let's look at an example. I want to know if my item is eligible to be agreed to planned quantity. So what do I have to see? Well, let's go to Article 311. We're looking at granular subbase. 311.08, method of measurement, has an item A, and the 2 words I'm looking for, contract quantities. If I see that and the reference to 202.07a, all right, item A, in my pay item, then it's possible I could agree to planned quantity. However, I cannot agree to planned quantity if the unit of measure is paid by weight. So what do? I go to the basis of payment and I look up my pay item. Here, first one I see is this one is paid by the ton. So if I have pay item 311, granular subbase, and it's paid by the ton, I can't agree to planned quantity. However, if I'm paid by cubic yard or square yard, those are things I can measure. I can measure cubic yards, a length, a width, and a depth. I can measure square yards, length and width. I can do that ahead of time for a planned quantity. However, do I know exactly how many tons of material it will take? I really don't. It's not always the same density, so I cannot agree to tonnage type items before we do the work. Here we see an example of the agreement on the accuracy of planned quantities. That's the long sentence that says agreement to planned quantity. It is the BC 981 form. It contains the most common items that are agreed to right here, and you can see the units of measure. What is one unit you don't see here? Tons, right? Yep, we don't agree to tons. This is the first page, one of two. Let's look at page 2. On page F21 in the dot guide, continuing on, this is page 2. We do see some weight units here. We've got pounds, but if we look closely, those are reinforcing bars, and we're going to calculate that. It's not paid by a weight ticket. Just remember, paid by a weight ticket cannot go on our BC 981. Here is the agreement prior to starting the work between the district and the contractor that says, hey, we agree that the existing conditions are accurate, the planned quantity is accurate, and we're going to go out and we're going to build it according to plan. We sign it, and there we go. We're ready to go. Please note, there are blank lines here at the ends, and we can add lines that aren't up here if we can see that item A, contract quantities, and reference to 20207A, and we don't have a tonnage unit, we can put it in here. Also, when it's being reviewed by the contractor or by the district and we don't agree on certain items, right, we can remove them with a single strike and initial it like this one. We crossed it out. We're not going to agree to that one, but we can keep all the other ones that we agreed to. So we need to check if planned quantity is accurate. On page F22 in your doc guide, you can follow along on some example planned quantity checks. Here we had earth excavation. We spot checked some existing grades to make sure that the plans represented the actual site. We looked at some cross sections. We performed some designed end area volume calcs. Everything looked pretty good. Therefore, we're going to accept planned quantity. Here we had some seating between a couple of stations. We quickly calculated the length and the width. We made a calculation for the acres. We came up with 11.5. There was only a 0.3 acre difference between plan and our check here. We didn't include the ground slope, so there's probably a little bit more that's actually out there, so we're happy. Therefore, we're going to accept planned quantity. We're going to skip down here to this concrete structures. Planned quantity was 383.5 cubic yards. We made a calculation based on the actual dimensions and found out we only needed 378.1 cubic yards. It's a difference of 5.4 cubic yards. Maybe that's not a lot of cubic yards, but at $425 per cubic yard, that was almost a $2,300 overpayment to the contractor. Well, that's not accurate enough. We're not going to accept it, so we struck that one out on our BC 981 and we agreed to the rest. Again, what does not belong on a BC 981? Granular embankment, contiguous earth and rock excavation. We don't know where the earth and the rock starts and begins. We can't quantify those. Tonnage or gallon items that are converted from a tonnage. So this is my paid by weight ticket items, not on a BC 981. Unit diameter for tree removal. Why would we not agree to tree removal? Well, what happens over the years? Trees grow and their diameters are likely going to increase. So we don't know accurately enough. We can't agree to this one either. Next section, we'll talk about progress documentation. We can either take a final field measurement on a daily basis, or we can have an estimated quantity. If we can't accurately measure it, or maybe we're agreeing to planned quantity, but we need to get that contractor paid on a minimum monthly basis, for progress, we can estimate. Most importantly, it is to document how the quantity was established, particularly if we're estimating. We're going to show you some examples in the next portion of the video. Estimating daily earth volumes with load counts. We're on the job site. They're going to be working on earth volumes for maybe a couple of months, and we're going to agree to plan quantity, or we're going to work off of before and after final cross sections for our total quantities. So we need a method to estimate as we're performing this work. We can do it by counting the loads, using a capacity of each piece of equipment, and then simply it is the number of loads times the capacity, and we're going to use a conservative factor of 80%. You can find this information on page A10 in the dot guide. We're going to use a specific capacity, struck capacity. A couple of ways we can find the struck capacity of our equipment. We can measure and calculate the volume of that piece of equipment by taking our tape and measuring 3 dimensions and calculating a volume. We could have the contractor provide a specification sheet, such as from Equipment Watch. There are many online equipment specification websites, or we can try to request it from the district estimator. Here we have a tandem dump truck. Here's the dump bed, and this yellow box would represent struck capacity. Normally, when they're hauling this material on site, what do? They heap it up over the top. They want to carry as much as they can. Well, I can't accurately quantify every time they heap it. So in order to pay for their labor, their fuel, and operation, contractors have agreed if we pay the struck capacity, which is the actual volume of the container, as if we took a straight edge and struck it off the top, then they are happy that they're getting paid enough to collect profit a little bit later down the road. Another example, maybe we have some scrapers with some pans on there. These are irregular shaped areas, so this might be one where I want to use a specification sheet. On page F23, we have an example of an IDR, or Inspector Daily Report, where we have calculated earth volumes by load count. We had 2 types of equipment here. We had semi-trailers and tandem dump trucks. We used the measurement method where we measured the width, length, and depth of each container. What are we doing at the end? Converting our units. We're dividing by 27 to go from cubic feet into cubic yards. Did the same thing for our tandem truck, got our struck capacities. We have the number of loads of each type times its capacity times our conservation or conservative factor of 80%. Gives us our estimated quantities. Here's our total. To fill out our IDR, we put our total estimated quantity and units. We have our pay item number, description, location. I check the box that this is an estimated progress measurement. It is not final. And I have my pay item number right down here on the line. Here's an example using equipment reference data sheets. The contractor used 3 Caterpillar 621Gs and 4 T-Rex TR45s. Each of the units, all 7 units, hauled 70 loads each. Let's look at how to find the equipment info. Sources can be from the manufacturer, auction houses, or subscription services such as Equipment Watch. Other sources could be contractors' purchase information, the actual data sheets on the pieces of equipment. We need to document this with a copy in our file and either attach it to the first IDR, or if you're in CMMS, you can upload it as a project document. Here's an example of online manufacturer data sheets. Here's the maintenance manual for our TR45s. Here's these big trucks we're hauling with. Right here in this little box, they provide the volumes of the hauling bed, and here I have struck and heaped. We are never using struck, never using heaped, pardon me. We will be using the struck capacity. Over here we see 25.6 cubic yards as a struck capacity. Here's an example of that Caterpillar 621G. All right, we got our scraper going on. Here is our volume. Down here we've made this larger. On the bowl we have our heaped and struck capacity. Always use struck, 15.7 cubic yards. If you're not sure and they give you capacity and they give you a range, you're always going to use a smaller one because that will be your struck capacity. Here's another, the Ritchie Specs auction house. Here's our T-Rex TR45. Again, here's my struck capacity. We can see it is the same as the manufacturer's information. On page F24 in the dot guide, you can see this IDR example. Here's our pay item number, description, our location is estimated. Check the estimated box, put our pay item number here. Here we had load counts where we had our TR45s. We had 4 of those units. Each of them hauled 70. Here's that 25.6 cubic yards per load times our 80% factor. We get our cubic yards. Here's our 621G, 3 units, 70 loads each. Our struct capacity, 80%. We got our other quantity. Here's our total quantity. That goes up here, our total quantity and our units. Looking pretty good. Next, we'll talk about estimating concrete and rebar. You can find this on pages A10 and A11 in the doc guide. For concrete, we're either going to extract the volumes from our computation check file or our calc file, or we can use a reasonable percentage of the actual delivered concrete. Recommended percentage for concrete that's reasonable, 90% of the delivered concrete. For the rebar, we're going to establish a rebar factor in pounds of rebar per cubic yard of concrete that are within our structure that we're creating. We can get this from the planned quantities that we've already checked and calculated. We use the concrete volumes as the one that's placed and then multiply that 90% times our delivered amount. Then we multiply by this factor. That'll give us the pounds of rebar. Let's show you an example. On page F26 is an example of calculating rebar and concrete for our estimating. We're on the job site. We have concrete tickets that total 43 cubic yards that were delivered. We multiply by our reasonable factor of 90%. That gives us 38.7 cubic yards as our estimated quantity. That goes here in our concrete structures. We have our estimated of 38.7 cubic yards times our rebar factor that we've calculated, 151.2 pounds of rebar for every cubic yard of structure. Here's our note that there's a total pounds of rebar and our total cubic yards in the structure. You can see right here where we've calculated the rebar factor, total pounds, total cubic yards. That's where we get our pounds per cubic yard. Here somebody made a miscalculation and the checker found it. We got a single line strike, new initials, new quantity. We're good to go. Let's go to the IDOT webpage and look for the Mystic conversion factors. So we'll go to IDOT Mystic conversion table. Here we go. Scroll down here. And it pulls up a PDF into your browser, and you can see here this is the Mystic Pay Item Conversion Factor Report from 2017. The pay item is over here on the left-hand column, and then we have the pay item name, the pay item unit, so this is the unit that it's going to be paid in, a material code, material name, and then we have material unit here. That would be how it's delivered. So this material is delivered in by tickets, by weight in tons, and then you have a conversion. That is the number of material units per pay unit. So this item would tell us it's 1.5 tons for every cubic yard. Let's go back and look at an example of this. If you scroll down, you can see there are quite a few number of these items, but we're going to go back and look at a Inspector Daily report where we use this pay item conversion to do some estimating. So here on page F25 in the documentation guide, you can see we are going to use our Mystic pay item conversion. Here we have PGE that was delivered from weight tickets. We added up our tickets at 153.8 tons. Our conversion factor that we looked at from the Mystic conversion factors on the IDOT webpage was 1.5 tons per cubic yard. So for every 1.5 tons that was delivered, for estimating, it should equal approximately a cubic yard. So here we have our tons, 153.8 divided by 1.5 tons for every cubic yard. We put a conservative factor of 90% just to make sure we don't overpay when we're estimating. So we get 92.3 cubic yards as our estimate for this material, Here we got that up here in our quantity and units. Again, checking the box, estimated, get our pay item number on that line. Another method of estimation, showing you how to document a logical, reasonable explanation for estimating. We've shown you some conventions that we would like you to use. Here's a case where we're putting in some storm sewer. Maybe we're in staged construction and we've done one half of the pipe run, but we haven't gotten to the second structure, so we can't measure between two structures. We measured one section of pipe and it was 7.5 feet. We put in 6 sections, so 7.5 times 6 is 45 feet. So we're going to put that in as an estimate, showing a logical method for estimating so that somebody who's checking our work can follow along and it's reasonable. The next few items are technically estimating. However, we're going to calculate final quantities and put them in as progress measurements or as estimated until certain criteria is met. It's a way to guarantee some of these live or living items are going to establish themselves and not die so that we get them replaced if that happens. Here for sod, we're going to pay 25% of the measured area upon placement of the sod. So we're calculating the final area of this sod placement and we're going to pay 25%. We'll pay the balance, or 75%, on acceptance of the sod. It's live and healthy condition at least 30 days after placement. Estimating woody plants. Got our trees and shrubs and that kind of stuff. Upon completion of the planting, mulch covering, wrapping, bracing, whatever they're supposed to do to install it, we're going to pay 90%. Upon inspection and acceptance of the plant material, or upon execution of a planting bond, then we'll pay the final 10%. So this planting bond is different than your contract bond. This is a bond specifically for these woody plants, and it basically states that if they die within the establishment period, the contractor will come out and replace them until we get one to live. So either we have accepted it or they get the planting bond, then we can pay the final 10%. On page A11 and page F28 in the doc guide, F28 has this field book page, we're going to estimate payments for traffic control and protection. What is the pay unit typically for traffic control and protection? Lump sum. Do they perform this pay item the first day they show up? Do they complete this pay item? Should we pay them the whole lump sum? Not really. There's a little bit involved, right? They got to maintain this traffic control over the duration of the work. So what we want to do is pay 25% of that lump sum after they get it installed and we inspect it and we approve of the setup. During the work that's protected by this traffic control, we're going to prorate 65% of that lump sum. Once they've finished the work and have removed all the traffic control devices from our project, we're going to pay them the final 10%. How do we do that? Here we go. Here's the date. They completed initial setup. I'm going to pay them 25%. Next pay estimate, I'm going to calculate a percentage of the work. Here I'm using the progress schedule. It looks like it's going to take 100 days to complete this work. So 18 days have gone by since the last pay estimate. So 18 divided by 100 is the fraction of work times 65%, that middle 65% of the lump sum. Or for this pay estimate, I'm going to pay them 0.12. I'm going to keep a total to date, because if my total to date reaches 0.9, I have to stop paying on an estimated basis and wait until it's all done. Here we have another pay estimate. Here we got 28 days. I'm going to pay 0.18. Another pay estimate, another 28 days. I'm going to pay 0.18. I'm up to 0.73. I'm still in good shape. Here on the last entry, all the traffic control is removed. The work is done. I can pay the balance that's due. And if I do my subtraction right, 0.27 plus 0.73 equals one lump sum. So on the last payment, they're going to get 0.27. If this number had been 0.9, this last one would be 0.1. Blasting residue containment disposal. When do we have this pay item? Well, typically when we're looking at bridge painting. The old paint, or previously we used lead-based paint, so we have to sandblast it off, but we have to contain it because once it's not on our bridge anymore, it is a hazardous material. This is typically a lump sum item, so we're going to pay, just like the traffic control, we're going to pay 30% of the lump sum the first day that they mobilize and get started. I'm going to prorate 50% of the lump sum during the removal work. I'm going to pay the final 20% when they are complete and they've removed all the equipment and materials from the job site and I have all my paperwork. I said this was a hazardous material. They have to take it to a licensed landfill, and therefore we want to get all of our waste manifests in order and our environmental compliance is all in order. Topsoil excavation and placement. This is a unique pay item where it includes both the activity of excavating the topsoil and placing the topsoil. Once we've removed all the topsoil that is required, we're going to measure it in its original position. That means the hole in the ground from where we excavated. And then we're going to pay them 50% of that final quantity in cubic yards. Then they're going to stockpile this material, and at some point we're going to ask them to respread or place it on the job site, either in the same spot or somewhere else. Once they've completed the placement portion, we will pay the final 50%. Let's look at an IDR. Here on page F29 in the dock guide, we have our pay item for topsoil excavation and placement. Here are the measurements that I took in the field. I have two areas. This is area 1, area 2, and I have stationing where I took some measurements of the width. Here I'm 80 feet, here I'm 85 feet wide, and this one's 125 feet wide. At this station I was 18 inches deep in my excavation. At this station it got a little deeper, it was 24 inches, and at the final station it remained at 24 inches, so I can calculate my volumes. I'm going to do that using the end area calculation. So this end area is a rectangle pointed into the page that is 80 feet wide by 1.5 feet deep. So right here I have 80 feet times 1.5 feet, and I get some square feet. I do the same for these two, where I have 85 feet by 2 feet, then 125 by 2 feet. To calculate volume 1, I take the average of these end areas and multiply by my distance between them. By the way, how many feet are in a station? Yes, 100. So if I have station 5 plus 00 and I have station 2 plus 50, the difference between those, or basically 500 minus 250, is going to equal what? 250 feet. So I have the average of end area 1 and 2 right here times 250 feet between them, and I get my cubic feet of material in volume 1. I do the same for volume 2. I average the end areas times the distance between them, or 2 stations, and I get my volume. I add those two volumes up, and I have to do my conversion because the pay unit is cubic yards, and I calculated cubic feet. So here's my final measured in place cubic yards for the entire removal operation. Here I take my final amount and I multiply by 50% to get my estimated quantity for the removal portion. Check the box, it's estimated. Here's my pay item number. Here is my 1449.1 cubic yards. I put a note, we'll pay the remaining 50% upon placement of the topsoil at a later date. On that second IDR, I could reference this IDR, this date of IDR, and I could extract right off it and say I'm going to pay the final 50%, which would be that amount. Items that must be final measured. I cannot estimate these items. Any removal items. Once I remove it, it's gone. I can't go back and measure it again. So I need to measure it at the time of removal. Piling, right? If I'm driving piles in the ground, I can't estimate. I have to measure that pile before I put it in the ground, and then I know exactly how much is left in the ground afterwards. Paid by weight items or paid by weight ticket items. Those have to be final measured. I have to calculate those weights at the time. I can't estimate them. Trench backfill. even though it's a cubic yard item, I can't go back and measure it again because we're going to cover up our trench backfill with some type of pavement or structure. Basically, any item that can't be measured later has to be final measured at the time of production. Let's talk a little bit about use of computers. With the invention of CMMS, use of computers is highly encouraged to produce electronic documents that can be loaded directly into CMMS. We can use calculation programs as long as they're verified and approved by your district. Electronic spreadsheets are very common and a great tool. There can be other software programs, but they must follow the guidelines of calculation procedures that are established by IDOT. If we're using spreadsheets, each spreadsheet must show the pay item number, the pay item description, and at a minimum the contract number. We have to show our input data. That would be our field measurements or whatever values are performing a calculation on. If you're printing it out and you have a subtotal, if more than one page is used, the results and how they're calculated. So basically I have to show an example formula. I must cross-reference to any other source documents. So let's say I'm taking measurements in a field book and then I put them in a spreadsheet for calculation. I would have to reference that field book or IDR. If you input your values directly into the spreadsheet, put a note on the spreadsheet that the input data was directly into the spreadsheet, and then the spreadsheet shall be your source document. Must be initialed and dated. If you're in I-Cores or a manual project, you will print out your spreadsheets and initial and date. That's where the subtotal comes in. If you span more than one page, each page needs a subtotal if it's printed. If you're in CMMS, you can have electronic initials and dates. No need to print it, scan it, and put it back in. On page F31 is an example of a spreadsheet, right? Here we're calculating reinforcement bars. We have the bar designation, its size, the total number of each of these bars, the length of each bar per the plan. Here is a decimal foot version of the length. So here's my input value of length. Here are my pounds per foot, and you can see the little asterisks down here. I've extracted this from Article 508 in the spec book, the pounds per foot of each size of rebar. Then my sample calculation tells me for a single bar, I take its length times its weight per foot, and I get pounds. So that's my total here. So I take this cell times this cell, and I get this cell. That's my example calculation. All right, subtotal would then be the number of bars times the pounds of each bar would equal my subtotal. So here, this cell is the pounds per bar times the number of bars would equal this amount. So I've shown those example calculations right here. Here I've got my initials and dates. This was an I-Cores project. They printed this out and they manually initialed and date. If this was in CMMS, these could be typed in, initials and dates. Want to bring this to your attention. For example, only the department does not provide, approve any electronic spreadsheets. It's up to the individual user to make sure all of your calculation cells are performing what they're supposed to. Now let's talk a little bit about field measurements with electronic devices. What are we talking about? Field measurements with electronic devices. Most commonly, this is your GPS total station or the mushroom sticks, right? You got the stick with the little GPR or GPS receiver on the top, and we're going out there and we're taking horizontal measurements, right? Or two-dimensional measurements. In the X, Y, or horizontal directions, these instruments are very accurate. In the vertical, or Z, these instruments vary quite a bit in their accuracy. So we're not using them for elevation just yet. The general rule for IDOT, since we don't have specific spec guidance on electronic measurements, devices that are used for electronic measurements, you must show sufficient documentation that it is calculating the area correctly and that a checker can check it. And two, they have to be able to meet the minimum accuracy in Section B of the DOT Guide for individual measurements and final calculated quantities. This IDR is an example out of District 5 on page F73, where they used one of these GPS survey equipment. And here we're documenting the program that's used, the equipment that's used, and then we have some attachments that show how did we actually calculate this measured quantity. The final statement is the measured quantity that we calculated from the program is very close to the planned quantity. Here was my planned quantity at 228.5. My measured quantity was 229. So therefore, I think it's pretty accurate and I'm going to use it. This was approved in District 5 as an adequate measure of documentation. Here on the next page, we have attachment 1 to this IDR. It's a screenshot of the calculation program from this measurement instrument that's showing here the grid coordinate points that we used for this median removal. It also shows the area that it calculated. Here's another screenshot that's showing the points we selected for it to calculate an area within these points. The next one, here are the points that we chose, and it's showing the actual grid coordinates. These would be required because you could plot these out and manually calculate the area that's between them. Here are a couple pictures of these devices. Here's my GPS receiver on top of my measuring stick, and I've got my input device here, and we're measuring some areas by placing it on the ground, taking a measurement, and it's logging. We would download that into our calculation program. This gentleman's doing the same thing. We've got some points that we're measuring. Maybe we're doing some patching, that kind of thing right here. I do want to say I'm not real impressed with the safety of either of these two individuals. This person and their spotter, who's taking the picture from this side of, like maybe you're taking the picture of this person. Well, what's the direction of traffic? They're coming at you here from this side. Nobody's looking that way. Same here. The photographer has his back to traffic, and I'm sure this truck that's about 3 feet away is going about 10 miles an hour through this job site, right? All right, be safe out there.